When you talk about having 3 labs, what does that mean? Like, what do you do in those 3 labs?
That is a very good question. So what we specialize in is weird payloads, and by weird I mean chemical, biological, manufacturing. Um, what nobody wants to do, because then you have all the aerospace problems, which are hardware and software, and we know vibration, shock, and all those problems typical of space, EMI, EMC. But now you add a component that is, how do I keep bacteria alive on the moon, for example?
Right.
Or how do I take this Fortune 500 company that it's a chemical company and test their products in microgravity? So I like fun challenges and I still like science. So the combination of that makes us develop these weird payloads, which NASA apparently likes.
Cool.
So are these kind of things? They're all very specialized types of payloads. It can be different every time. You're kind of one and done, and then you move on to something.
That's also a great question. We try not to do that. So what we developed under a contract was a universal payload interface. So our computer can interface with 20 vehicles with no engineering. So we just change the top, like a Lego structure.
Yep.
So when it comes to building payloads, right, we don't want to be that one and done. And actually, we're scaling our Ares payload, which is our manufacturing for sensors. It carried 400 samples on the last slide, and we're thinking how to do that for Starship eventually and high volume situations. But no, we hate one and done. We hate it. We don't want to become a government contractor, a typical one. We want to do things that are reproducible and that other people can use, right? Our universal payload interface is being used by people that want to do drones and other industries as well. So no ones and dones.
Okay, so how's that going to work? Because here's the thing. I mean, you want to build universal types of interfaces. I know at least 2 or 3 other companies, one in Europe called JBoss, that they're doing the same thing.
Mm-hmm.
So is there a race to build the best standardization models, and hopefully you'll win?
That's a great question. So the General Electric play, right, becoming the plug for all appliances, if you will. That's one thing, right? That's just a plug. In our case, it's power and comms. EcoAtoms has a different trick, right? Which is very public. You can go to our website and download the payload interface guide. It's not a secret, but we work with computers, right? We work with FPGA-based systems. So you're not buying a connector. You can build your whole experiment like a very advanced Raspberry Pi situation, because we want to eliminate those Raspberry Pis out of the system. But now you have a computer that makes decisions in the pico nanosecond, right? So we are not a connector, we're a build-up payload. So you are saving from 200K to millions in engineering, depending on your project. So no, we don't want to be the connector, because that's a very cheap interface that can be plugged and play. We do want to be able to connect your experiment, that might be bio, chem, sensors, in a seamless way to the rest of the vehicle, which is a little bit different from the place that we've seen out there. Doing a connector is not difficult. Doing a computer that connects all these peripherals to all these vehicles, that was fun. That was a lot of fun for the engineering team when, what's the input voltage? And I came with a range,
Okay, so the future is actually in adapters, right?
Yes, but I would say expensive adapters. Let's put it like that.
Yeah.
They're a little bit expensive, just a bit. And adapters that, again, can, if paired with GPUs and CPUs or high performance computers, can do machine learning. So these adapters are special adapters.
Yep. I'm going to comment to Jason. Yeah, we have a guest on the show often named Cube, and they are also working on interfaces. We, our team, Tom and I, we've been really pushing the idea of interconnectivity, standards, modularization, Lego. We're sick of saying it, but we keep saying it because it's so important. We had a guest on our show now twice. His name is Dr. Mark Levinson. He wrote a book called The Box, and it might not seem relevant to our industry, but I promise you that it is. He is a historian and an economist that that watched the development of Connex shipping containers and how standardizing the box changed global shipping. And our industry right now is exactly at the place that the global shipping industry was in the 1950s.
Look,
And
I just bought the book. I'm a big fan of design. Um, I love Dieter's Ram's work, right? Which is this engineering guy from Brown or design. I don't know if he was even an engineer. Um, and developed all these racks, all these plugs, all these appliances. And I feel like we're not solving a physics problem here, right? We're just solving design. And I feel like
Mhm.
if somebody invented a container or invented a better blender, we can learn from all those stuffs, you know? Smart people are in all industries. So I try to take that and make it my own. Our payloads are inspired in Japanese junctions. So if you see them, they're going to feel very unfamiliar because they're not the typical mid-deck locker that you see in the ISS or those typical standards. We went for a plug and play closer to Japanese design. So I'm a big fan. Just bought the book. We'll see. We'll see how that goes.
nice, very cool, very cool.